love drinking soda like it's water. We squeeze lemon on everything. We use soap without a second thought. But what if I told you all those three things belong to the exact same chemical family, and depending on how strong they are, they can either be totally harmless or literally dissolve metal? That is really cool. Now, I know chemistry can sound very intimidating, but we've all heard words like acids and bases in our science classes at some point. But what's actually happening when vinegar fizzes with baking soda? Why does your stomach not digest itself? We need to actually understand this. Welcome to another episode of the Insightful Butterfly. Let's get started. Before we get into the chemistry, let's start with the one tool that makes all of this make sense, the pH scale. Picture a number line that goes from 0 to 14. On the far left near 0, you've got acids, things like lemon juice, vinegar, or soda. On the far right near 14, you've got bases, things like soap, bleaching, and baking soda. And right in the dead middle at 7 is neutral, plain water. That's the whole system. Low number, acid, high number, base. 7, water. You don't even need to know the deep chemistry behind why. Here's the part that actually makes people surprised. This scale isn't like a normal ruler where every step is the same size. Every single number you move is actually 10 times more intense than the number next to it. So, something at pH 3 isn't a little more acidic than something at pH 4. It's 10 times more acidic. Move two numbers from 4 down to 2, that's 100 times acidic. That's exactly why your stomach acid sitting at around pH 1.5 to 2 isn't just kind of acidic, it's absurdly acidic. Way more acidic than vinegar, which only sits at around pH 2.5 to 3. Your body is running something close to industrial strength acid inside you, on purpose every single day, just to break down your food. Now, let's talk about what happens when an acid and base actually meet. This is called neutralization, and it's the same reaction behind that classic baking soda and vinegar volcano you probably made in 3rd grade. The acid and the base cancel each other out, and one of the leftover products is a gas, carbon dioxide, which is what makes it fizz and foam. That exact same reaction, just happening slower, is what makes bread and cakes rise in your oven. But here's where it gets more interesting. Why do we even react to acids the way we do? If you've ever bitten into a lemon, you know your face does something automatically. It scrunches up before you even consciously decide, I don't like this. That is not random. Researchers at Duke University Medical Center, working with University College London, found that our ability to detect bitter and sour flavors likely evolved as a survival tool, a built-in warning system that helped early humans avoid eating poisonous or spoiled food. Your brain learned over thousands of generations to treat sour and bitter as tiny chemical alarms, long before anyone knew what pH even was. So, that instinctive face you make biting into something sour, that's not just taste, that's ancient survival wiring, reacting to real chemistry happening in your mouth in real time. Understanding this changes how you look at basically everything you eat, clean with, or put on your skin. You don't need to memorize every acid and base out there. You just need to remember the scale. Remember that it jumps fast, and remember that your own body is quietly running this chemistry every single day without you even noticing. If you like this video, make sure to like and subscribe and hit the bell notification so that you don't miss out on new updates. Thank you for watching, and I'll see you in the next video.